Hello everyone, welcome back to Diksha Vedantu Foundation channel, and today is day 76 of 99% in 99 days, and today I am going to discuss about the sample paper 6. So if you are following our series, you already know that we have completed all the chapters, all the concepts, all the previous year questions. Now we are doing sample papers, okay, as published by NCERT website, or sometimes sample papers are almost scarce. So what we are doing, we are currently solving the question papers, that is from the previous year question, whole question paper as a whole. And the question paper is getting provided in our WhatsApp channel. You have to join our WhatsApp channel. The link is given in the description. From there is a given link. You have to click on that link, and all the question paper is getting updated on the same link every day. Whatever questions we are discussing, the same question paper you can find from the link in the WhatsApp channel. Okay, so don't waste your time. Join the WhatsApp channel today and get ready to the journey towards the success. Right, now let's see the makeup of this paper. So question paper consists of 5 objective question. Out of the 5 objective question, 4 is MCQ and 1 is assertion and reason based. We have 1 2-mark question, we have 4 3-marker question, we have 5 1 5-marker question and 1 4-marker question as usual. So let's start with the section 1, that is 1-mark question. So first we are going to discuss the MCQs, right? So let's see the question. The circuit below, question number 13. In this is the question number 13. If you have the PDF of the question paper, you have to download it and you have to follow us. The circuit below consists of a variable resistor connected in series with 2 2000 ohm resistors. So here we have 2 2000 ohm resistors, right? So one 2000 ohm is here, another 2000 ohm is here. The variable resistor can be adjusted to any value between 0 to 4000 ohm. So this is a variable resistor. You can use the knob to change the resistance, and it can be varied from 0 to 4000 ohm. The resistance of the variable resistor is changed. What is the smallest possible reading of the voltmeter? What is the smallest possible reading? Smallest possible reading means the voltage drop across this is smallest. That means the current in the circuit is the smallest, right? We know that voltage drop across any resistor is basically I into R, right? So IR is equal to voltage, that is the Ohm's law. So, and if R is fixed, now to get the reading smallest, we have to have the smallest I. Now how can I have a smallest I in this circuit? So if you observe that here all 3 resistances are connected in series. All 3 resistances are connected in series. So more the resistance, less will be current. To get the more resistance, what we have to do? We have to fix this variable resistance to the highest possible value. That is the main question. Otherwise, this is a very simple question. So this variable resistance should be fixed at 4000 ohm. So what is the total resistance? Total resistance is basically 4000, that is the variable resistance, plus 2000 plus 2000, that is 8000 ohm, right? So this is the total resistance. Now voltage is given as 12 volt, V is given as 12 volt. This is the supplied voltage, right? Supplied voltage is 12 volt, so we have to calculate the current first. Current is basically given by V by R equivalent, that is 8000 divided 12 divided by 8000. 12 divided by 8000. This is the current. This is the current, right? Now what is the voltage drop across it? We already know the formula, I into R. So I is 12 by 8000. No need to do the division here, because we will soon multiply with the resistance of the resistor, that is 2000. We are trying to measure the resistance across this, right? So we will multiply with this resistance. So 0 0 0 0 0 0 cancels. We get 4 4 12 is 3, right? So 3 is the correct answer. Correct answer is 3 volts. So lowest possible voltage is 3 volt. If you keep this resistance lower, then definitely this will increase, the voltage will increase. Okay, now let's move on to the next question. The frequency of AC in some countries is 60 Hz. What does it mean? So we know that in our household electricity chapter that we use AC current, right? AC current is used in our household circuit. Now what is the meaning of the term frequency? For example, in India mostly we use either 50 Hz or 60 Hz based on certain conditions, right? So now if we say that in India we are using 60 Hz AC, that means it changes its direction. Okay, AC current, basically what is the meaning of AC current? AC current means alternating current. That means it changes its direction every time, right? So normally DC is represented by a straight line, whereas an AC is represented using a curved line like this. Okay, this is called a sine graph. You will learn about it in detail in your class 12 chapter, where you have a detailed study of alternating current if you are studying science, right? So basically that means current is positive and then current is negative. This is called one cycle. So it is changing its direction 60 times every second. That is the meaning of the frequency term 60 Hz. So it current changes the direction 60 times in a second. Okay, so in one oscillation it changes its direction from positive to negative once. Okay, and it is oscillating 60 times. 60 Hz means it is oscillating 60 times. Now each oscillation the direction is getting changed once, so that means in 60 oscillations the direction will be changed 60 times. So current changes, not current, voltage also, you can mention voltage also, but since they have given here current only, so you have to answer it using current. But actually in reality we are using we are consuming voltage. The power supply comes in terms of voltage. So basically voltage is also changing 60 times per second. 60 times per second. Very, very interesting question. Now another question, Raman wants to draw a graph to show how the resistivity rho of a wire changes with the length L of the wire. What should he show? What should the graph look like? So we know that resistance is basically given by rho L by A. This is fine. But we also remember that rho is independent of length. Rho is independent of length. Rho depends only on temperature and the material. So it will be a constant graph, and constant graph means only constant is here is this. So rho is constant over the length. Okay, as the length increases, rho remains constant. Rho does not change with the variation of length. Very, very interesting and very, very intriguing question. Okay, very thought-provoking question. So you have to be careful while answering such questions. Okay, many students might think, okay, constant, this may be also a constant graph. This is not a constant graph. Okay, this is a length is constant in this case, but rho is changing, rho is increasing. But in reality, rho is constant. That means rho will give you a flat line. So no matter whatever is the length, the value of rho will be constant, that is this value. Okay, so this is how it is done. Question number 16. So here we have a circuit. Okay, which circuit shows the correct and safe positions for the fuse and the switch? Okay, so they have given a few options. Now in each case circuit will work, but there is only one diagram where everything is correctly done. What is that? So the correct answer is option A. So you see that the fuse is connected to the live wire, and also the switch is also connected in the live wire. Okay, because if you don't do that, if you apply the neutral wire, okay, if you apply the switch to the neutral wire, there is a high chance you will get electrocuted if you try to change the bulb. Okay, if you try to change the bulb, the live wire is always live, so there is a connection always present in the circuit, so you will get electrocuted if you do not apply the switch to the live wire. The amateur electricians, so those who are just started working and they have no knowledge of the circuit, they think, okay, if I apply switch to any of the wire, it will work. So they what they do, they by mistake they connect the positive or live wire to the switch, it directly, and negative or in the neutral wire to the switch. So it is working fine, but there is a high chance that you will get electrocuted because of this mistake. Very careful. Okay, and the fuse obviously has to be connected to the live wire, because if any current increases, the live wire should break, not the neutral wire. Okay, it should break the live wire, so that whenever you are replacing, you should replace the live wire, so that there is no chance of getting harm either for human or for the device. So fuse has to be connected to the live wire, switch also has to be connected to the live wire. Okay, let's move on to the next question. Assertion and reason. So what is the assertion? Assertion is stationary charged particle placed in a magnetic field experiences a force. So stationary charged particle placed in a magnetic field experiences a force. Reason: a stationary charged particle does not produce a magnetic field. So stationary charged particle does not produce a magnetic field. This is a little higher level question, and this sample paper, in my opinion, is slightly older, so that's why these concepts are no longer part of your syllabus. Okay, so the moving charges produce magnetic field. So moving charges produce magnetic field only, and then only the magnetic field, they interact with each other, and then only it will experiences a force. Static charges does not experience any force. Okay, so stationary charge placed in a magnetic field experiences a force is a wrong statement, so assertion is incorrect, but reason is correct. Reason is correct that stationary charged particle does not produce a magnetic field. So stationary charged particle does not produce a magnetic field definitely gives you the reason to say that okay, this is the reason is correct. Now if there is a option that experiences no force, in case the question was experiences no force, then in that case assertion and reason both are correct, and reason would be the correct explanation of the assertion, right? If there is no magnetic field, so for example we know that one magnet gets attracted when it is kept near another magnet, right? Similarly, a charge which is moving produces a magnetic field, and then only it interact with another magnetic field, that is another magnet, right? So it has to be a magnet to interact with another magnet. You cannot interact with non-magnet, right? You cannot interact, suppose you are a human, you cannot, or you are an animal, you cannot interact with the wall. Okay, so because wall is not an living agent, it cannot react to whatever you are saying, right? So that is how it is. So if magnet wants to interact, it has to interact with the magnet only, right? So both no, A is false, R is true. So in this case A is false, R is true. So next time if you see the same question with saying that no force experienced by a stationary charges and the reason is given same, then definitely you have to choose option A. So this is a trick question. In case the question is repeated but with a different language, you have to be careful. Next question. White light passed through a prism yield a spectrum. Okay, so we know that when white light is passed through a prism, we observe 7 different colors, and that is called spectrum. The ray of which color will show the maximum angle of deviation, and which one will show the least angle of deviation? Easy question. A blue colored ray is passed through a glass prism. What will be the color of the emergent ray? Justify your answer. Again, easy question. Or myopia is known as nearsightedness. A person with this defect has the far point nearer than infinity. Okay, so myopia is a defect which is known as nearsightedness. That means you can see nearby objects clearly and you cannot see far objects clearly. Far objects appear blurred, whereas nearby objects appear clear, because the far point is the distance at which we can see the farthest, and our eye can see objects which is at infinity as well. So for example, the stars that we can see in our night sky. Okay, so stars, if they are bright enough, we can see them, because they are, even though they are very far away, we can still see them because our eyes are adapted to that, right? So that is the farthest distance that we can see. Okay, so if you are suffering from myopia, the far point comes closer. Okay, far point comes closer, that's why you need a spectacle. Draw a ray diagram, draw a neat ray diagram, depict image correction for myopic eye using a suitable lens. So what type of lens we will use, that you have to identify and you have to answer this question. Let's see the answer. So let's see the first part. 0.5 marks for each correct answer. Okay, maximum angle of deviation is violet color ray. Okay, we have seen that the scattering or deviation happens least for red. So red will definitely have the smallest deviation, right? That's why when white light enters prism, after refraction the red light appears like this, whereas violet light, it bends the most, right? So red, this is red, this is violet, right? So definitely we know that red light deviates the least. Okay, that is the property of light. Higher the wavelength, less is the deviation. Okay, so that's why red light deviates the less and violet deviates the most. Okay, so if you answer both of them, you will get 0.5 each, that is 1 mark. Now 0.5 marks each for the both correct points. Okay, since blue color ray cannot be split any further, it will pass through the prism undeviated. Okay, the emergent ray will be blue in color. Obviously blue light is part of VIBGYOR, right? So it will give you blue light even after it emerges out of the prism, and because it cannot be split into any more colors, you will get the blue light as a output, right? Now let's see the neat diagram drawn with the following components marked. Light rays coming from infinity, concave lens in front of the eye, lens of the eye, image from the retina, 0.5 marks, no marks to be awarded for incomplete diagram. So you have to complete the diagram. The diagram is given in your book, you can check that out. I'm not going into that detail. This is a very common easy question. So also remember that if you draw the diagram incomplete, so for example, if you don't put the arrows or if you miss the convex lens, you will be getting no points, no marks by mistake. Let's see the question number 30 now. Okay, so this is a 3 mark question. An object of height h is kept at a point P in front of a mirror as shown in the image below. So here we have an object kept at a point P. This is a concave mirror. Okay, the height of the image produced is h dash. So this is the height of the object. Suppose the image produced wherever it is now h dash. Okay, in the diagram. So here we know there will be a inverted and image will be produced. Okay, inverted and enlarged image will be produced because it is kept between C and F. F is the focus and C is the center of curvature. If the object is now moved to point C, now this object is moved to point C. Okay, now what will happen? Will the height of the image now produced be less than equal to or greater than h dash? Okay, so here it was h dash. Now we know that if the object is placed between C and F, the image height is generally greater, right? Image height, not generally, image height is greater because it is the property that we have learned while drawing the ray diagrams as well as studying. Now when we kept it at C, the image size is exactly the same of the object. So h initially, h dash was greater than h. Now in this case, suppose this is h double dash, so h double dash is now equals to h. So h double dash will also be less than h dash, right? So this is the property. So first question answer already done. Give a reason for your answer, because you have to mention that. We will see that answer exact in detail. So let me read the next question. If the focal length of the mirror is 20 centimeter and the distance between the point P and C is 10 centimeter, determine the distance between the images produced when the object is kept at P and C. Okay, so very interesting question. So first they have given you that the focal length is 20 and this distance is 10 centimeter. Okay, now they have asked you to find the image distances in both cases. Okay, let's see the answer. Very interesting question, is going to be interesting question. So the height of the image produced when the object is at C will be less than h dash. As I said, the magnification is more when the object is point P than at C. So I always give you one example, that suppose you are starting at infinity, you are approaching a concave mirror. Okay, so when you are starting at infinity and slowly approaching the concave mirror, initially your image size is very small. As slowly you are approaching the mirror, okay, your image size is now increasing, but still it is less than your original size. Now as soon as you reach the center of curvature, at that point your image is now equal to you. So the size of your image and size of you are now equal. Now if you keep approaching the mirror, okay, then your image size will keep on increasing. Now it will be backwards. Okay, you will slowly move towards the mirror, and the image will be keep on increasing till you reach the focal length. At the focus you will get an infinite size image, right? That will be very far away. But if you cross the focal length, then definitely the image will be now erect, and it will be a virtual and still magnified. So only between infinity and the center of curvature the size of the image is smaller than that of the object, and exactly at C the height becomes same, and any distances less than C the height will always be greater than h, the image height. Right, so magnification is more when the object is at point P than point C. So you can explain it in slightly detail, but 1 mark is for correct answer. As soon as you mention the correct answer, you will get the full marks. Okay, to find the distance between the two images, we need to find the image distance when the object is at P and then when it is C. Okay, to find the image distance when the object is at P. So first we have to see that this is given 20. This distance is given as 20. So what is the let me clear all the mess. So this distance is given as 20. Okay, and this is given as 10. Now we know that this is basically double that of 20, right? So this is 40. This is 40 means what is this distance? This will be 40 minus 10, that is 30, right? So this is 30 centimeter. Clear? So basically this P point is middle of C and F, right? So if this is 20, then total distance will be 40. If total distance is 40, 40 minus 10 will be 30 is the object distance U. So now you have to use the length equation. U is equal to minus 30 centimeter, F is equal to minus 20 centimeter. So as I said, for concave lens, focal length is negative and object distance is always negative. Now using the mirror formula, you can calculate the first position to be minus 60 centimeter. You can use the mirror formula, 1 by V minus 1 by V plus 1 by U equals to 1 by A. Just put the values, calculate the V, you will get V to be minus 60 centimeter. Okay, to find the image distance when the object is at C. So when the object is at C, the image will also form at C. So the image distance will be 40 centimeter, right? Since C is certain center of curvature, the image distance equals to object distance, that is V2 will be minus 40 centimeter. Okay. So 1 mark for finding V1, 0.5 mark for finding V2. So distance between images are 60 minus 40, that is 20 centimeter, 0.5 marks for the finding the difference. Right, so be careful when you are answering this question. Okay, first part is 1 mark, next part is 2 mark, and in the next 2 mark only calculating V1 gives you 1 mark, 0.5 mark you are getting when you are finding the object distance when it is at C, which is very easy. And last but not the least, where you find the difference to get extra 0.5 marks. Now let's move on to the next question. A lens forms a blurred image of an object as shown on the screen as shown below. So here we have an object. Okay, if the screen was placed somewhere here, we would have got a clear image, but because the screen is slightly backwards, we are getting a blurred image over here. Okay, so only at this point we will get a sharp clear image, but the screen is not there. In any other position, if it is in the forward direction or in the backward direction, we will not get a sharp image. Okay, sharp image in What changes can you make the following from the sharp and in focus image of the screen? Object distance, can you change the object distance to get a sharp image? Focal length of the lens, can you change the focal length of the lens to get a sharp image? Okay, so what we have to do, we have to mention, you have to increase the object distance or decrease the object distance. Similarly, you have to mention what you have to do with the focal length, increasing the focal length, decreasing the focal length. So based on that you will get marks, right? 0.5 marks each. Sunita's ophthalmologist suggests her to use a lens of power -2D to correct her vision. Ophthalmologist means those who check your eyes, okay, eye specialist. Okay, they can check the eye power. Okay, there are different expertise in the case of eye. Some are specialist in surgery, some are specialist in checking your eye condition, power, etc. So this is the ophthalmologist do, they check the power of your eye. What type of lenses should she use? Okay, what should be the focal length of the lens? An object is kept at 10 cm in front of the lens of power -2D. Find the distance where the image is produced. Let's see the answer. So first, decrease the object distance because the image is forming before reaching the screen, so you have to decrease the object distance. You have to bring the object closer to the lens so that this distance again matches, so that you get the image formed on the screen. What else? Increase the focal length. If you increase the focal length, it is a very strong lens, that's why it is getting focused closer. If you increase the focal length, then what happens? The lens is now having higher focal length, focuses at a point which is farther away, right? So these are the two things that you have to understand. This is an understanding level question. Okay, if you miss it, you will not get marks. So 0.5 marks for each correct answer. Now what type of what is the question? What type of lens should she use? Lens of power -2D. So -2D lens means it is a diverging lens or concave lens. Okay, as I said, negative focal length, negative power represents concave. Okay, it's maybe a lens, it may be a mirror. Negative represents concave. Now here, since we are talking about eye correction, that is person who is wearing glasses like me, okay, so they are wearing a diverging lens, okay, negative power. Okay, focal length is basically 1 by power, that is equals to 0.5 meters. Okay, 0.5 marks. No marks are to be allotted if the negative sign and unit are not mentioned. Very, very careful. Negative sign has to be mentioned, the unit has to be mentioned. This 1 by P formula stands true for meter. The unit should be in meters. Okay, so also here you have seen that the focal length is now converted into centimeters. Okay, you can do that in this case also, no, not to worry. Anyway, now you have to use the lens formula. The U is given, power, from power you calculate the focal length, you have to find the V. So V turns out to be -8.33. Okay, 0.5 marks for the use of correct formula and 0.5 marks for the correct calculation. So 0.5 marks you get to use the correct formula, and then after using the formula, once you input the values and correct the calculation, you get another 0.5 marks. Very careful. Okay, now another question related to Sunita. Sunita had to replace the electrical plug of her clothes iron. Okay, she bought a 3-pin plug as shown below. I think the 3-pin plug images is missed. When she removed the old plug, she saw that there were 3 wires colored red, black and green. To which pin on the plug should she be connect the green wire? To which part of the clothes iron is the green wire connected? State the function of the green wire. So everything is related to the green wire only. Direct contact between which of the 3 colored wires will result a short circuit. State what happens to the current in the circuit in the case of a short circuit. Give the reason for your answer. Okay, let's see the answer for this question. Pin P, so pin P basically means the top pin. Okay, so if this is a 3-pin plug, say this is P, Q, R, then this is the top plug where you should connect the green, the top one. Okay, so green connect always be to be connected in the top most single pin. If you have a 3-pin plug at your home, you can remove it. You can check that there is a top single pin, that is the green pin. Okay, it is where it is connected. It is connected to the metallic body of the electric connection. Why to the body? Because in case there is a leakage of electricity into the iron, electric iron, that current, extra current will be carried to the ground by this green wire. Okay. It prevents severe shocks by providing a low resistance path for any leakage current to the metallic body of the iron. So if there is a leakage of current, you will get a shock, but that is a mild shock. That will be a mild shock. It will not harm you. But if there is a no green wire, then you will get a mild shock that can be fatal to you as well. You might die if you get that high voltage shock. Okay, the red and the black wire. Okay, what is the question? Direct contact between which of the 3 colored wires will result in a short circuit. So if you directly connect red and black, red is the live wire, black is the neutral wire. If you connect them, there will be a short circuit. Okay, there is a drastic increase in the current. Reason, the resistance of the circuit decreases. Resistance basically becomes almost zero. Short circuit means when live wire and the neutral wire are connected. In that case, current gets a very low resistance path to pass through, and that is why there is a very high amount of current passes in the circuit, and that can damage all the devices in the circuit. Right, now let's move on to the next part. Ozone formation takes place in the stratosphere of our atmosphere. Explain how energy of the sun helps. I think this is not a physics question. Okay, this is not a physics question. Anyway, let's move on to the 5-marker question. Okay, P and Q represent 2 straight wires carrying equal current I in a direction perpendicular to the plane of the screen towards K is the midpoint of the line joining P and Q. The image shows the magnetic field lines around the wire, but the direction of the magnetic field is not marked. Draw the above image, and so this is kind of an image P, Q and K. Okay, so if the current in the wires is increased, how will the strength of the magnetic field around P, Q change? Draw the magnetic field lines around P and Q to represent this change. If B is the magnetic field at point K due to the current in wire P, what will be the magnetic field due to P and Q at the midpoint K? Give the reason for your answer. If B is the magnetic field at point K due to the current in the wire P and the current wire Q is reversed, what will be the magnetic field at midpoint K? So let's see the answers. So first of all, we know that there is a straight wire carrying current P, Q and K. So because of the straight wires, the this is not a current carrying wire. By the way, this is a current carrying wire, this is a current carrying wire, and because there is a current, through this current is going, through this current is coming. Okay, so it will be a circular concentric circular magnetic field lines. We know that for a straight current carrying wires, it will be straight current carrying wires, it will be a concentric magnetic field, and if you point your fingers towards the current, then the circles, you can draw the circles with the direction. In this case, current is going into the paper, so you will have to be careful. Okay, so they have given the arrows in the wrong side anyway. Right, no, so okay, both wires are carrying current into the paper only, so that's why this is in this case also this way, this is also this way. Okay, so this is also same way, both wires are carrying. So actually the main circuit is missing. Sorry for that mistake. I will try to update it, but you can check that in the question paper given in your sample paper PDF. You can download it and you can check it. Right, so this is how the current is going. So both will be concentrated circular coils. Okay, the strength of the magnetic field around P and Q will increase. If you increase the current in the circuit, the strength will increase. To represent increased strength, what you have to do, you have to draw more number of lines in the same area. Be careful. So if you have drawn, so for example, here you have drawn 1, 2, 3 lines. Here in the same region you have to draw 1, 2, 3, 4, 5 lines. So if you see, the size of the images are almost same. It is not, may not be appearing, but in the same region you have to draw draw more number of lines. So for example, if you draw lines using your compass, okay, suppose you have taken 1 centimeter, 2 centimeter, 3 centimeter. Now you have to take 0.5 centimeter, 1 centimeter, 1.5 centimeter, 2 centimeter, 2.5 centimeter, then 3 centimeter, like that. So you have to show more number of circles in the same region to represent increased magnetic field. Okay, 1 mark for correctly drawing more number of field lines to indicate the stronger magnetic field. Okay, and 0.5 marks to explain the part. Okay, and I think for this diagram you get 0.5 marks or 1 mark, I think 1 mark, yes. Now what is the magnetic field at the center point K? It will be 0. The magnetic field at point K due to current wires P and Q are equal in magnitude but opposite in direction. The two fields cancel each other. So if you see, due to this wire, the magnetic field is in this direction, okay, in this direction, and due to this the magnetic field is in this direction. Okay, so they are equidistant, so it's a midpoint, same current is passing, so this magnetic magnetic fields will be equal also. So two equal magnetic fields will cancel each other. So two equal magnetic field cancelling each other means the net magnetic field will be 0, right? Net magnetic field will be 0, right? Answer D. What was the question D? Let's see the question D. If B is the magnetic field at point K due to the current in the wire P and the current in the wire Q is reversed, what will be the magnetic field at midpoint K? Now what happens? Now they are saying that so suppose we have a magnetic field at B. So this was the initial case. This is point P. Okay, and due to this the magnetic field here is B. Okay, now what they have done in the wire Q, they have reversed the current now. So in first case, both cases current was coming out of the paper and magnetic field is at point P, K it was equal and opposite. Now they have made the magnetic field the current in the opposite direction, so both fields will equal and in the same direction. So this will be B, this should also be B, and they will add up, so total magnetic field will be 2B in this case. Okay, so if you reverse one of the current, the magnetic field will immediately be double, okay, than one single wire. Okay, clear? Little tricky question. This question paper is slightly trickier and slightly harder than most of the papers that I have seen, but anyway, you have to answer. If the question paper is hard, it is hard for everyone. The image below shows the design for a refracting telescope. Okay, so this is a refracting telescope. So there is a objective lens, there is an eyepiece. When the light passes through the prism, different colors split and dispersion takes place. The same thing happens with the lens, but to a much lesser degree. This is called chromatic aberration and causes the different colors of light to focus at different points. To overcome this problem, the reflecting telescopes was invented. One design of the reflecting telescope is shown below. Okay, so we know that when you can consider a lens to be sum of small prisms. Okay, small prisms having different angles. So basically this was how we used to learn. Now they have changed it a little bit. Okay, so a lens can be considered to be sum of individual prisms. Now because prisms has a tendency to disperse colors in white light into 7 different colors, same thing is happen to a lens as well. Okay, even a lens can disperse white light into 7 colors. That is called chromatic aberration. Chromatic means colorful. Okay, aberration means anomaly, which is not intended to be there. Aberration means which is out of the equation. So if you get some question which is never asked before, it will be an aberration, right? So this is called chromatic aberration. To overcome this problem, the reflecting telescope was invented. One of the design of the telescope is shown below. Now let's see. why there is no chromatic aberration in reflecting telescope. Now they have given all the description about refractive telescope. Then they are saying that why there is no chromatic aberration in reflecting telescope. Now they are saying, okay, we are now using reflecting telescope. So if you have followed my class, this is called Cassegrainian telescope, Cassegrain telescope, or Cassegrainian telescope. Both are correct. One of the critical factors affecting a telescope is the amount of light it can gather. The more light a telescope can gather, the better the image it produces. What can be done to the lens to increase the amount of light a telescope gathers? If the refracting telescope given in the passage, what should be the distance between the two lenses? Use the first ray diagram in the passage to answer it. The light that reaches the telescope comes from a very far away celestial objects. Draw a ray diagram to show what happens when the light from a far away object falls on a convex lens and a concave lens. Okay, so let's see the answer. So this is the answer, and there is also one extra question, but I think that answer is not given. Okay. Extra question is, or the light that reaches the telescope comes from a very far away celestial objects. Draw a ray diagram to show what happens when the light far away objects falls on a convex mirror. And they have, so first case is convex lens and concave mirror, and now they have convex mirror and concave mirror. So both are mirror, previously both are lens. So both things you have to do. Let's see. Light does not pass through a second medium, and hence there is no refraction and splitting of color. So the dispersion happens when light changes the medium, right? So we have observed that when light is traveling through a prism, due to dispersion, light is traveling from air to the prism, then prism to air. So multiple times it is changing its medium. So as soon as the medium changes, the velocity of light is changed. So velocity of light changes means all the colors traveling at different speeds, so they disperse. But in case of reflection, all the lights are still traveling at the same speed. So white light remains white light, red light remains red light, so color does not change. So chromatic aberration is no longer there in a spherical mirror. Okay, increase to get more light, what you have to do? So the question was how to get more light from distant object. To increase the size of the lens or size of the mirror. If you increase the size of the mirror, you get more light from the object, right? Increase the diameter aperture of the objective lens, primary mirror. So either you increase the diameter of the aperture of the lens or primary mirror, you get more light. Okay, equal to the sum of focal length of the objective and eyepiece. I think this part is deleted now. This is not a part of the syllabus anyway. So here we have the diagram when light ray from a very distant object, that is parallel rays, falling on a concave convex lens, and it is focusing at some point. In case of concave lens, it is getting diverged and it is appearing to come from a single point. Okay, 0.5 marks for convex lens and concave lens ray diagram. So 0.5 marks for each. Similarly, for mirrors, convex mirrors, they diverge the rays and it appears to come from a point, and concave mirror, they converge the light and they focus at a focal length, right? So this is the simple diagram. So I hope you enjoyed this session. I will be back with sample paper 7 next week. Till then, bye.